While B cells fight pathogens primarily with antibodies, humanity would have died out a long time ago, and we talked about this last time. The first time we came across a virulent pathogen if it weren't for the T cells. T cells are the ones that identify new diseases. T cells attack pathogens without the need of an antibody. They eradicate new pathogens. So the T cells are very important, and this is one of the reasons why HIV was so destructive. It was so destructive because they couldn't identify new pathogens. And for this reason, if they came in contact with something new, like Kaposi's sarcoma or pneumocystis pneumonia, they weren't able to fight it off. And so these guys with HIV, of course, a lot of them just died of pneumonia. A lot of them died of the flu. But we were seeing really strange diseases, and at that point, we had been into the thousands of people dying of HIV, and at that point we realized we had something really serious, and that this could be a very, very serious problem if it expanded in the United States. And of course, we were watching this happening all over the world, and the place where it hit the worst was Africa. And the reason it hit so badly in Africa is because of their sexual practices. It didn't have anything to do with homosexuality like it did in the United States. What it had to do with was the fact that in Africa, if your wife is pregnant, you can't have sex with her. So then you have sex with your number 2 wife, or number 3 wife, or number 4 wife. Well, what if you have them all 4 of them pregnant at the same time? Or if they're menstruating, you can't have sex with them while they're menstruating. So what are you going to do? Well, you're going to go visit a prostitute, of course. Of course. Silly. So since that was part of their culture, they developed a heterosexual HIV reaction. And because of that, and it got worse. It just got worse in Africa. So the vast majority of people with HIV live in Africa, even to this day. It's like 24 million. Lots of people have died. Whole villages have died of HIV, leaving the children as orphans. So there are a lot of orphan villages in sub-Saharan Africa. Most of this is in the rainforests of Africa. So if you go into the southern portion of Africa, I told you that last time. They had an outbreak of Ebola virus in the Congo. 66 people have contracted the Ebola virus. Something that we're all deathly afraid of. If you contract Ebola, the probability of you surviving is fairly remote. And we're not exactly sure we can develop an antibiotic that will work on this stuff because you die so quickly. What happens is you hemorrhage, and your organs hemorrhage. And you bleed out, and you die. That's why you die. You don't really die, well, you do, but you die in just a couple days. And unfortunately, anything that comes out of you is contaminated. So all the blood that comes out of you, all the sweat, so everything is contaminated. So it's very easy to contract that disease. So one of the things we have to do with Ebola is we have to quarantine. If it starts in an area, we have to quarantine that area. We don't let anybody out. Well, what does that do with the people that are in there? Are they all going to die? And you've probably seen television shows about this. They talk about bombing the village or napalming the village and that kind of stuff. That's one of the ways to keep it out of the rest of the world, but of course we're not allowed to kill innocents. T cells do this with 3 types of cells. Cytotoxic cells are killer cells that attach to one type of antigen. Estimates are that T killer cells can recognize at least 1 million pathogens. This is good news. Helper T cells and suppressor T cells secrete chemical messengers called lymphokines, which work on other immune cells. Helper T cells wander the body looking for antigens. When they find them, they send out chemicals to attract other immune cells. They are inhibitory as well as excitatory in that they control an overzealous response. We talked about this last time. An overzealous response would be a case of autoimmune infection or disease. RA is the most prevalent autoimmune disease that we have. When a pathogen is able to establish itself within the body despite the activity of the immune system, a sickness response is triggered by the hypothalamus, called the acute phase response. The reality is we're around diseases all the time, and usually our immune system takes care of it. But sometimes if we're immunocompromised, potentially we will come down with a disease. If we have been introduced to that disease before, probably our immune system will keep us from getting sick. The flu every year affects a lot of people, and the reason it affects a lot of people is because the flu this year ain't the same as it was last year. It's different. Most of the flu is made up of influenza type A and influenza type B, but every year it's a different configuration, and that's the reason that so many people come down with it, is because it's a different configuration. We try to guess what it's going to look like, and that's what the flu shot is. So we give you the flu shot, and potentially the flu shot should keep you from getting sick. But last year it was only 35% effective, which meant that 65% of the people that got the flu shot got the flu, despite the fact they have the flu shot. I'm not sure what it is this year. This year it's been kind of delayed. It started relatively early, then we had it plateaued, and now it's getting worse again. And the reason it's getting worse is because of the weather. We've got really cold weather in the Midwest. 2 million people were under that polar vortex. 200 million people, I'm sorry. 200 million people were under the polar vortex. They've got sub-zero temperatures in the east this week. So because of that, we got a really serious problem going on with the flu. It's coming back. Look at the weather that we're having. If you remember last year, did we have snow that lasted for weeks? I don't think we did. I don't remember this kind of weather. I don't remember sub-zero temperatures here last year. But we've had a couple days where it was below zero in the morning. So because of the weather, the flu is making a comeback. And it's making a comeback because people are more, because you're trying to stay warm, you're more immunocompromised. And since people are more immunocompromised, they're coming down with disease with the flu. So the acute phase response looks like this. You have fever, you have inflammation, usually of your joints. Reduced activity, reduced food intake, reduced water intake, increased sensitivity to pain, disrupted memory consolidation, so this isn't the time to study when you're sick. Increased anxiety, usually there is a degree of anxiety. The acute phase response kicks in about an hour or two after the infection starts. Sometimes the whatever it is, whether it's a bacteria or a virus, has to incubate. So if Chris and I shook hands and Chris had, I don't know, what do you want to have?
Just a cold.
Just a cold. He's got a cold. Do you have a cold? Okay. If he had a cold and I shook hands with him, the rhinovirus, which is what most colds are caused by, the rhinovirus, it would take about a week for that rhinovirus to build up enough viruses in my system to make me sick. So I wouldn't get sick like 2 hours from when I shook hands with Chris. I'd get sick in a week. I'd catch his cold in about a week. This is one of the reasons why in elementary schools the teachers are sick so frequently, because all their kids are younger, and because they're younger, their immune systems aren't as strong, so they come down with just about everything or anything, and it will run through the class, and they'll have, a third of the kids will be sick any given day, and then the other third will get sick, and then the other third will get sick. It's really kind of interesting. And of course we're watching the teacher of course is an adult, but because she's around all these sick kids all the time, she usually comes down with the same disease. As a lab tech, I came in contact with all this stuff. I came in contact with just sick kids. I didn't come in contact with healthy kids. We rarely treated healthy kids. So I didn't get sick at all. And the reason I didn't get sick was because I was being introduced to the virus or the bacteria. And so I never got sick because I was being immunized, naturally immunized, by coming in contact with this stuff on a continual basis. The brain is informed about the infection because the chemical messengers called cytokines, pro-inflammatory cytokines accelerate inflammation. There are three pro-inflammatory cytokines. Tumor necrosis factor is one of them. Interleukin 1 and interleukin 6 are the three pro-inflammatory cytokines. Cytokines are produced by the first immune cells that arrive, and those cells are the macrophages. The macrophages are there to engulf whatever it is, whether it's a virus or a bacteria. It's there to engulf it. And it puts off cytokines, and then the brain knows that there is a problem. If cytokine production is blocked, the individual can have an infection, but no acute phase response. They won't act sick because they are fighting off. They're going to fight off the infection. Cytokines are actually too large to pass through the blood-brain barrier, so they send their message to the brain by attaching to receptors on the vagus nerve. So this is the vagus nerve that runs from your brain stem all the way down to the bottom of your gut. So it will attach itself to the vagus nerve. As soon as an okay, so we're done with the immune response, and of course we cure ourselves by being sick, and it'll run its course. Whatever is going to happen will happen. A lot of times the human body will overreact to any disease process. In other words, when you get a cold, the first day you probably still had the cold virus in your nasal passages or in your sinuses. And that's why you blew your nose so much. The second day you didn't. All that virus was dead. It was gone. But of course your body wants to make sure that it is gone. So you will continue to have a reaction. So you will continue to blow your nose a lot and cough. You'll create a lot of mucus. And that's how the human body fights off a rhinovirus, is by producing a lot of mucus. So if you only blow your nose for a couple days, then you probably didn't have a cold. It was probably an allergic reaction. But if you blew your nose for 7 days, then it was probably a disease process. How about that? But you were only actually sick the first day. Second day you probably weren't sick anymore. You will not catch that rhinovirus again because your body is already keyed to it. You have already produced T cells against it. You've already produced antibodies against it. So you won't get that disease again. If you get another cold that season, it's another type of cold.
Is it a cell that's a memory cell?
Right. Exactly. And that may be there forever. Well, probably not with a rhinovirus. The reason that we catch colds every season is because there are so many different rhinoviruses out there. And some seasons are worse than others. Sometimes these rhinoviruses will mutate and all of a sudden everybody's got it. Everybody's got the same cold. Now you guys are lucky. Well, you guys are smart. Let me call you smart instead of lucky. If we lived in the city, if we lived in Flagstaff, if we lived in Phoenix, if we lived in Chicago or New York, we'd be sick all the time because all these viruses would be all over the place. If you taught in a school, then you potentially would be sick all the time. Either you'd be sick all the time or you wouldn't be sick ever at all because you would come in contact with these and you would become immune to them. That's why I never get sick. I'm immune to everything. Because I was a lab tech. And I got, lucky me, came in contact with all that snot. Isn't that sweet? My doctor used to take baggies, and he would collect snot from people, and I would take that snot and I would send it to the lab to find out what kind of
What
influence.
sort of tips would you give a lab tech?
What about
Not getting sick?
not getting sick? I don't know. Some of them get sick all the time. It all depends on whether they're immunocompromised. This is really weird, because if you're a happy lab tech, you never get sick. If you're a grouchy lab tech, you get sick all the time. I know. It has to do with whether you're happy or whether you're sad. So the one thing I could tell all of you is that stay happy. If you stay happy, you won't get sick. How's that? And it works, as strange as that may seem. I never got sick. Never caught hepatitis, never got the flu, you know. And I know that this stuff was the flu because I sent the specimens off to the lab to be identified, and they came back type A, type B, whatever type of flu it was. Anyway, and I never got sick, despite the fact I'm spleenless. People without spleens are supposed to be immunocompromised, but I don't seem to be. I know, there's something wrong with me. Write that down, Sharon. There's something wrong with it. Oh, she probably says that on every page. There's something wrong with me. Okay, so we're going to talk about how we got born or whatever. We're going to fertilize an egg here. Let's fertilize an egg. As soon as an ova is fertilized, the entity is referred to as a zygote, and the clock is ticking on the germinal phase. The big conflict going on, a lot of controversy about abortion right now. Louisiana has passed a law that once the heart starts beating, you can't abort a fetus. Of course, that was thrown out by the Supreme Court. Virginia tried to ban late-term abortion. They tried to ban a late-term abortion. And the Supreme Court looks like they're going to uphold that late-term abortion is, you can't do that. Now, why would somebody have a late-term abortion? Now, this is real controversial. But they seem to be arguing two different points. Why would you have a late-term abortion? Why would somebody have a late-term abortion? Can anybody see any rationale for aborting your fetus in the third trimester? Does anybody know?
They didn't know they were pregnant.
I'm
They
sorry?
didn't know they were pregnant.
That's not usually the reason. But no.
Illness?
I'm sorry?
Illness?
Illness. Whose illness?
No.
That's a possibility as well. It may mean death for the mother. That's one of the reasons. But the other reason has to do with the baby's non-viable. In other words, if the baby is born, the baby will probably die because of some genetic problem. One of the problems we're having right now is mutations. One of the things that we have discovered this is a Canadian study, and actually this is a relatively old study. There are genetic changes. There are epigenetic changes to an individual's DNA if you smoke marijuana. This is especially true of males, not so much females. But it changes the sperm, makes it less motile. I mean, there's a lot of different things that it does. But they've discovered 600 places that it causes methylation on the DNA. So it changes who the baby would have been if the old man smoked pot. At this point, we're not really tying marijuana to any of these oddities that we're seeing. But in the future, we may. And of course, in the future, we may have legalized marijuana. But in Canada, they've had legalized marijuana for a while. In New Zealand, they've had legalized marijuana for a while. So This is some really interesting and some scary stuff. We could see mutations in the future. We already know that if you smoke marijuana before the age of 13, that you're changing the structure of your brain, and potentially you're reducing your IQ. I keep talking about this stuff. As soon as the ova is fertilized, the entity is referred to as a zygote, and the clock is ticking on the germinal phase. The germinal stage lasts for the first 2 weeks of life and doesn't end until the zygote implants itself into the uterine wall and ties itself into the mother's circulatory system. As soon as the ova comes out of the ovary, the ova can be fertilized. And if it is fertilized, right as it comes out of the ova, it will probably be a female. If the ova is migrating its way down the fallopian tube, and then it is impregnated, it will probably be a male. Okay. If it migrates its way almost into the uterus before it's fertilized, it will probably be a female. How about that? It turns out that male and female sperm are not the same. Male sperm are heavier. They don't swim as fast. So if the individual is impregnated at the beginning of their ovulation, then the offspring will probably be a female. If it's in the middle of their ovulation, it will probably be a male. If it's at the end of their ovulation, it will probably be a female. None of this is absolute. Of course, none of this is absolute. They used to talk about position of intercourse, creating more males and female babies. I'm not sure if they're even talking about that anymore. Probably inaccurate and incorrect.
Does it depend on the chromosome, X and Y?
Excellent. Yeah. We're going to talk about that in a minute. Yeah. Okay. So, most babies that are created are male, as it turns out. There tend to be a lot more male sperm than female sperm. And they're heavier, they're bigger, they're meaner. I don't know if they're meaner. They're sperm. Come on, let's get real. From the 3rd to the 8th week, the entity will be referred to as an embryo, and the stage is the embryonic stage. This is a very dangerous time for the baby. This is usually when a baby is spontaneously aborted during the first 8 weeks, during the first 2 months. If you're going to lose a pregnancy, you'll usually lose it in the first trimester, within the first 2 months. First trimester is the first 3 months, but we won't go into that. After the 8th week, the entity enters the fetal stage, and the structure becomes known as a fetus. As a fetus, actually as an embryo, it kind of looks human. It's just a mass of cells, of course, and then it becomes a baby. A full-term pregnancy is 38 weeks long. That's what we talk about in the hospital, 38 weeks. So how long are you? Anything between 35 and 38 weeks is considered full-term. So you can have a baby at the beginning at 35 weeks, and you're good to go. Some women don't have their babies for 42 or 45 weeks, and that's post-term, and that's not fun because the baby's big as a truck. My poor mother. She had 6 kids, and my youngest brother was late. She figured that the reason that my youngest brother was late was because she was starting to go through menopause. And so her hormones weren't quite as what they should have been. So she knows exactly when she got pregnant, and she hits that 38th week, and she starts swearing. My mother swore like a sailor. Let me tell you, that lady knew all the words. And she started swearing at 38 weeks. Well, she went all the way to 45 weeks, and the baby still hadn't come. And she wanted them to induce labor, but they wouldn't do it. The doctors wouldn't do it. She's getting bigger and bigger. My mother was only 4'8". She's only 4 foot. She weighed less than 100 pounds. And here she's got this monster baby inside of her. And so at 45 weeks, she finally went into labor. She said it wasn't very good labor. You know, she used to talk to me about this stuff. It wasn't very good labor. I didn't think I was going to ever get that little shit out of there. Anyway, so she finally goes into labor. At that time, they used to just knock them out, and then they take them into the delivery room, and they wouldn't wake up for like 12 hours. You know, they'd just knock them out. And so my brother's born. He weighs 11 pounds. My poor mother, who normally weighed about 85 pounds, here she's got an 11-pound alien structure in her body. That poor thing. It was a vaginal birth. Had all kinds of problems afterwards. Ripped her from stem to stern, getting that baby out. She had hemorrhoids. I mean, she had all kinds of horrible problems with my brother. He weighed 11 pounds. He had so much fluid on his system. He was 7 weeks late. His arms, they took a picture of him, and his arms are stuck straight out because they're full of water. His arms and his legs, he looks like a balloon. I mean, it was that bad. It's the ugliest baby you ever saw. He's still the ugliest kid in the world. The women think he's gorgeous. Jeez, pisses me off. I showed you a picture from he was the tall one on the end. Oh, shit. Did you think he was pretty? Yeah, you did. Maybe, I don't know. Anyway, he was 45-week gestation. Anyway, normally anything over 35 weeks is considered okay. Anything before 35 weeks is considered preterm. As I told you, my daughter was 43 when she got pregnant with my grandson. Of course, she's a biologist. You know, I'm a psychologist. I teach this lifespan development. I know all about this stuff. She knows all about this stuff. So throughout her entire pregnancy, she's calling me every week and saying, "Dad, everything's okay. You know, I'm not spotting. You know, that kind of stuff. Everything seems fine. I'm throwing up really good." So I got the message all the way across. But at 22 weeks is about what the baby can survive. So we were trying to make it to 22 weeks. We wanted to make sure everything was okay. And she made it to 22 weeks okay. And of course I told her at about 18 weeks, I told her that, of course she's 43, so there could be all kinds of horrible things wrong with the baby. At 18 weeks, she had a alpha-fetoprotein done, and he was fine. Everything was good. And at that point I told her, well, you know, some babies are viable at 21 weeks. And so that made her feel a little bit better. But the kid went all the way to full term, happiest baby in the world, never cries. I mean, he's just the most amazing baby in the world. Just never cried. But sometimes he would have bad dreams, and he'd wake up crying. It's the only time he ever cried was from these bad dreams. We haven't figured that one out. He's a really happy kid. He's 6 now, so evidently everything's okay. Each sperm and ova will contain 23 chromosomes, so that after fertilization, the chromosomes will match up to create 23 pairs or 46 total chromosomes. And this is what we're looking at. This is what it looks like when we do a chromosomal map on somebody. As you can see, the mom and dad, their chromosomes don't always look the same. The last one is the sex chromosome. As you can see, the X chromosome is much larger than the Y chromosome. Y chromosome is like a third, only has a third of the chromosomal material. And for that reason, if she has a problem on her X chromosome, if she has a disease on her X chromosome, the boy will not be able to cancel that out. If it's a little girl, then it'll be 2 X chromosomes, and you'll have 2 complete chromosomal masses here. And so the old man's chromosomes may cancel out whatever problems are on her X chromosome. But if it's a little boy, no, it doesn't work that way, unfortunately. And for this reason, we have a lot more males who have problems than females. And a lot of it is sex-linked. In other words, it has to do with the fact that they can't cancel out all the bad stuff that's on mom's X chromosome. It always follows the mother. It has to follow the mother. Because if it was on the father's chromosome, he would cancel it out. Maybe. Unless both of them have the same problem. Hemophilia is a good example. How many females do we have with hemophilia? It's really rare in females, but it's not that rare in males because it's on the X chromosome. And if it's a male, then the father's chromosomes will not cancel it out. That's the way it works. Is this good news or bad news? Well, if you're a male, it's kind of bad news because, you know, you're SOL. Big time. So if mom's got a problem on her X chromosome, you've got that problem. Whatever it is. Male pattern baldness is a good example, not that that's a really serious problem. Male pattern baldness follows the female line. In other words, it doesn't really affect females unless two people with male pattern baldness marry each other and it's on his chromosome. Then the woman, the female, will be bald, or have that male pattern baldness. We see that very, very rarely. How many bald-headed women do you really see? Not very many. It's really quite rare. But of course, we see it in men all the time. We also see men shave their heads. And I haven't figured that one out yet. I don't know why they do it. The last chromosome in the sequence is a chromosome that determines the biological gender of the child. The biological gender of the child is determined by the male. My brother-in-law had 4 daughters, and it pissed him off. And he kept shaking his finger at my sister because she had all four female children, and he wanted a boy baby. She never made him one, so it must be her fault, right? No, it was his fault. He was only shooting, well, I don't know what he was shooting, but it only made female children, whatever it was. And maybe she was just getting pregnant at the beginning of her ovulation. Or maybe at the end of her ovulation, probably at the beginning of her ovulation. That's why she had female babies. Over are always female or X's, and this is what an X chromosome looks like. This is a female child because, well, it's got 2 X chromosomes. It is the male chromosome that determines whether the baby will be born as a male or a female. A sperm with an X chromosome or a Y chromosome, as I said, looking at, and we can do this. If you want to be artificially inseminated, we can separate the male and the female sperm. We can take a semen sample and we can spin it down, and like I said, the male sperm are heavier than the female sperm. And we can separate them that way. And we can make a male baby. You know, they're bigger. They're heavier. They swim slow. Female sperm swim really fast. And that's one of the reasons why if you have intercourse at the beginning of the ovulation, that the female sperm will win the race. They will get there first. Right in the middle actually, this has a lot to do with alkalinity and acidity. If we look at semen is very alkaline. And the reason it's alkaline is to neutralize the acidic female reproductive area. Female reproductive area is very acidic. And the reason it's acidic is to protect it from bacteria and viruses. Cannot live in that environment. Can't do it. It's just too acidic. And in order to neutralize the acidity, the male has to have alkaline semen. And the more alkaline it is, the more he will neutralize it. Now here's the kicker. During in the middle of her ovulation, her reproductive area becomes less acidic, right in the middle, making it more likely that the male sperm will actually win the race. Okay, there you go. Sorry about that. But most of the time, the female reproductive area is being protected by a very acidic environment. And this, of course, keeps her from getting an infection. If she ever gets an infection in her uterus, her cervix, if any of this stuff ever becomes infected, she can't have babies anymore. And of course, we see this all the time, this kind of stuff all the time. My second wife she couldn't get pregnant. She was trying to find anybody that could get her pregnant. Nobody could get her pregnant. I couldn't get her pregnant. But then they went in and they checked her out, and what they discovered, they did a histocytopengiogram where they punch a hole in her belly button, and they went in and they looked around to see what was going on. And what happened was she had, her fallopian tube had adhesed to her rectum, her colon. So it had attached itself to her colon. And because of that, it had pinched off her fallopian tube. So here this lady was ovulating, but the ova were never migrating all the way down to her uterus. So she was having periods, that wasn't her problem. The problem was that the ova couldn't make it down there. Luckily, it was adhesed to the point that sperm couldn't get through the fallopian tube. Otherwise, it would have been she would have become pregnant. The zygote would have grown in her fallopian tube, and it would have blown out her fallopian tube.
Cystic fibrosis.
It's called, wait a minute, ectopic pregnancy. Ectopic pregnancy. Okay, so she got it fixed. We don't do this procedure in the United States, but at the time she was stationed in Holland. She was stationed in the Netherlands, and they did the procedure. And so they pulled her, they went in there and they pulled her fallopian tubes and they straightened them all out as best they could. So the next month she got pregnant. Isn't that exciting? She finally got pregnant.
So you had to physically go on there and
Yeah. They didn't probably with their fingers. They probably used, I don't know. Anyway, they straightened it out. Next month she gets pregnant, and lo and behold, there's still too much of a kink in her fallopian tube, and that sucker didn't make it all the way down to the fallopian tube. Blew her fallopian tube out. Well, this is highly vascularized area. Your fallopian tubes are very vascularized. And she almost bled to death, as horrible as that sounds. Of course, I wasn't married to her at this point. She was working on number 3, I think, or number 4. Number 4. I was number 3. I was number 3. Or was I number 2? No, she was my 2, I don't remember what she was. Anyway, she got pregnant, and it blew out her fallopian tube. So she was afraid to have sex after this. Because she was afraid she'd get pregnant again, and she would have another ectopic pregnancy, and she would never be able to have babies. So she became celibate until she could afford to have artificial insemination. Don't worry. Eventually she had she had a set of twins, a boy and a girl. And she named them, named them after my kids. Roxy and Chris. She named them Roxy and Chris.
Oh my gosh, that's so weird.
She was out of service at that point, and she was living in Georgia. Anyway, and I was all the way in Nebraska, so I didn't have anything at all to do with her pregnancy. No, I didn't have anything to do with it. Okay, each cell of the human body contains the same genetic fingerprint or deoxyribonucleic acid, the DNA, the famous DNA that we talk about so much. Only the individual sex cells, the sperm in the males and ovum in the females, do not contain the 46 chromosomes. Sex cells only contain 23 chromosomes apiece. It's very logical because they have to match up, and then they make 46. At the 2-week mark after fertilization, the zygote must implant on the uterine wall. If all factors aren't perfect, the zygote will not implant, and it will be swept out of the uterus along with the menstrual flow. And that happens a lot. It happens a ton. If everything is not perfect, the pregnancy will not begin. Well, actually, it's already begun, but it will not take place. So the zygote will not implant itself on the uterine wall, and everything's over. Does she know that she was pregnant? Maybe. Maybe she knows. Can she turn a pregnancy test positive before it implants on the uterine wall? Yes, because what we're measuring is human chorionic gonadotropin. And as soon as the cells start to reproduce, they start, mitosis starts. They start splitting. As soon as that happens, the mother's immune system can kill it. So in order to protect itself, it creates a substance that tells her body that it is not something to be killed. And this substance that it creates is a substance called human chorionic gonadotropin. As exciting as all that is. And so that will protect that entity. So she will not kill it. Her immune system won't attack it and destroy it. But it has to produce all this human chorionic gonadotropin. Each cell has to produce its own human chorionic gonadotropin. So the more cells she has, the more human chorionic gonadotropin is produced. And this will get into her urine and it will tell her if she's pregnant. That's why Clear Blue Easy turns positive or whatever. In the old days, it took her like 2 months to produce enough of this stuff before we could detect it, but now we can detect it after about 2 weeks. So we can see if she was pregnant. And we see a lot of pregnancies that don't last past 2 weeks. Why? Because everything wasn't perfect. Has she spontaneously aborted? Yeah, I guess you could say that if you like, but it's only been 2 weeks. A lot of women think that they might be pregnant because their period is late, and then all of a sudden they're not pregnant anymore. Is this okay? Probably it's better, because if she were getting pregnant and not everything was perfect, then potentially the baby wouldn't be perfect. But it is very, very rare for a baby to be born that isn't perfect. It's very, very odd. It doesn't happen very often at all. I used to work in Children's Hospital in Omaha, and we would get all the strange, the babies that were that had problems. We get all the babies with problems, and we got them all from Iowa, western Iowa, and southern South Dakota, and Nebraska. We got all of them, and there were not that many. Not that many at all. Most of these babies never make it to full term. Something usually happens, and usually they are spontaneously aborted in the first trimester. So it's not that debilitating to the female. She doesn't carry a pregnancy that's not going to be a viable offspring. This is the way it works, okay? For this reason, it is rare for somebody to give birth to a baby that doesn't survive. It doesn't always happen. It happens relatively rarely. Spontaneous abortions. Fewer than half of all zygotes implant properly on the uterine wall. Of course, everything has to be perfect, like I said. If the uterine wall isn't prepared properly, if there's not enough vascularization to it, then the zygote will not implant. And that's just the way it works. So everything has to be perfect, as exciting as that is. With the embryonic phase, the structure begins to look like a human being. The brain begins to develop. The head begins to form in the 4th week. Primitive heartbeat begins to beat between the 4th and the 5th week. This is really controversial. Some people say, no, it's 18 days after fertilization, the heart starts beating. That's not detectable. It isn't detectable. We can't detect a heartbeat until about the 5th week. That's a month and a week. That's 40 days? 47 days, 37 days, yeah, 37 days. Not 18 days, 37 days. Okay. By the 9th week, 2 months, the embryo is 1 inch long and weighs about 1 gram, which isn't very heavy at all. All the adult organs have formed except the sex organs, and the structure starts being called a fetus at this stage. In the 9th week, sex organs develop, and if the fetus is a male, the testes begin bathing the fetus with copious amounts of testosterone. There's a reason why men act like men and women act like women. Women have estrogen and men have testosterone. And this starts in the womb. So the male brain ain't the same as a female brain. And the female brain, of course, isn't the same as a male brain. The male brain tends to be larger. Not that that means has anything to do with intelligence, even a little bit, obviously, because most women are all stupid and most men are. It's sad. It's sad. Don't cry, Travis. You'll be okay. It changes the structure. Now, what if, so where do people who are gay come from? What's going on here? Why are they different? Is it the environment? Were they born gay? The assumption is now that people who are gay are born gay. And the reason they're born gay is because potentially something happened in the uterus. And it changed the structure, it changed things. Too much cortisol can decrease the amount of testosterone. So the male brain, which is actually, it's different, isn't the same. Remember, all female ova are X's. So females want to have girl babies every time. That's all you have. You've only got a female ova. So estrogen is the norm. We saw what the chromosomes look like. The male chromosome is really short. Whoops. The male chromosome is really short. This is like less material than you're supposed to have. This is how much you're supposed to have, and this is how much they actually have. So this is more natural than this is. Well, that's one way of looking at it anyway. Okay, so if something happens and it lessens the amount of testosterone being produced by the testes, then potentially it'll change the brain. So what happens with somebody who's a lesbian? Well, potentially they were actually the testes produce estrogen as well. Produces estrogen as well as testosterone. So maybe it had more testosterone than it was supposed to have. How's that? So that gives you a reason why people are gay. This is really controversial. But this would explain why throughout human history there have been people who were not heterosexual, were homosexual. It's logical. We see it in every culture, not just European culture, not just the American culture, but all cultures. There were gay people in the Americas when the Europeans first got here. They've been around forever. Okay? It's not an abomination, all right? I don't know. The Bible wasn't written until 2,000 years ago. I guess that abomination didn't start until 2,000 years ago. Anyway, all right. So it's a natural thing. It's the way things work. Something happened to the individual, and it changed the amount of testosterone being produced, or it increased the amount of estrogen being produced. Anyway, this is a natural state. And of course now, you know, we talk about people being transgender, and we talk about people being asexual, and you know, all kinds of interesting things. I imagine all this will change in your lifetime. My lifetime is almost over with, so I don't have to worry about it. But you guys will have to think about this stuff. Between the 4th and the 6th month, the brain will increase in size by a factor of 6. So it's exploding at this point. It is really expanding. Starting in the 4th month, brain cells will increase exponentially at the rate of 500,000 cells per minute. So there's a lot going on in the brain. This is not a time to be messing around. The baby's brain is being developed at this point, in the 4th month. She's starting to show. She needs to stay away from things that will disrupt the structure of the brain. Most of the toxins that you ingest potentially will change the structure of this brain if she does it in the 4th month. Now the old man, he's done. He's already screwed his sperm up. I mean, he's all finished. She's 4 months into this pregnancy, and she's got 5 more to go. And she's got to be a good girl, no matter what the old man's doing. He could be token all the time. She needs to stay away from him. She needs to stay away from him when he's smoking, because secondhand smoke. She needs to stay away from alcohol. She needs to stay away from tobacco. Potentially, she needs to stay away from caffeine, even though caffeine, we haven't proven that caffeine can do anything with her. But she really needs to stay away from alcohol. Alcohol has an affinity for brain tissue. We know that. If I feed Francis a couple shots of tequila, it goes right to his brain. Sorry. It goes to my brain too. And he's an adult. You know, his liver is fully developed. The baby's liver isn't developed at all. It's there, but it doesn't metabolize alcohol. So it goes right to the brain, unfortunately. And we've got 500,000 cells being created every minute. So if she goes on a bender in the 4th month, potentially she's going to have a baby with FAS or FAE. So this is the time to stay away from this kind of stuff. Stay away from anything toxic. Stay away from chemicals. Yesterday I was coming, Marius had, oh God, Marius, I swear, sometimes he's just a pain in the ass. He had to have a hamburger. And he can't walk over there by himself. So I walked over with him. And he got himself a hamburger with onions. Oh, man, are you white? He's not white. I tease him all the time. Anyway, so as we were coming out, I opened the door. I grabbed the door. And there was oil under there. I know. There was oil. They had lubricated the door or something. And I got a handful of oil. Well, potentially that's poison. I mean, that potentially could have been poison. But here, it was on the door handle, and I got it all over my hands. And then, like an idiot, I licked it. Trying to figure out what it was. So I poisoned myself yesterday with all this stuff. And it's Marius' fault, right? He had to have a hamburger and I had to go with it. Okay. You see it's Marius' fault, right? Okay, good. It was his fault. Okay, so they're creating 500,000 cells per minute. Babies have survived as young as 21 weeks, but viability normally begins about the 22nd week. For the longest time, anything was around 30 we could save. Anything before that, it was questionable. But now we are so good at this that we can save a baby that's 22 weeks old. Their brain is not fully developed yet. So at 22 weeks, we're going to have to keep them in an incubator for an extended length of time, potentially for weeks until their brain develops. My niece had a set of triplets. And 2 of the triplets were okay, but one of the triplets was undersized. One of the triplets wasn't getting as much nutrition in the uterus. So she was in the hospital for 3 months after she was born. The other 2 got out of the hospital in like a week. They were all born young because, well, she's not a very big person and she's carrying 3 babies in her womb. So I think they were born at 28 weeks, if I'm not mistaken. But of course, 2 of them were normal size, relatively normal size for a 28-week-old fetus, but the other one was undersized. So they said that she looked like she was 21, maybe 22 weeks gestation. Not that she was produced at the same time, she just wasn't getting as much nutrition in the womb. She was at the end, she was like the runt. She was not getting as much nutrition. Anyway, she was in the hospital for an extended length of time. We didn't think she was going to make it. Now, the interesting thing about that child is that the other two have perfect eyesight and she has bad eyesight because of the oxygen. They had to pump oxygen into her incubator to keep her going. What else happens? Oh, she's got all these autoimmune diseases. She's asthmatic, she's got skin disease, and the other two don't have any problems at all, which is really kind of interesting. But you can see the difference between the three girls. They're all cute little things. I mean, well, one of them's tall, like my brother. Each day of growth within the womb during the last trimester increases the fetus possibility of survival. And for that reason, you try to take your child as long as possible. You try to keep them in the womb as long as possible. And this is the reason that they didn't induce, this is why they didn't induce labor in my mother. They thought that she was stupid. They thought that she didn't know when she got pregnant. You know how doctors are. Doctors are a lot smarter than you are. So you can't tell them, Jack. Yeah, okay. Anyway, so that's why they kept the baby in there. And she's getting bigger and bigger and bigger, of course. Of course, she's only 4 foot 8. She's this tiny little thing with a, she's got as much stomach as she looked like the Octomom, you know, that lady that had 8 babies. She looked that big. She was just big as a truck, poor thing. Finally, she gave birth to the baby, and then she cussed out that doctor, up one side and down. You couldn't kill my baby, son of a bitch. What the hell's wrong with you? I told you when I got pregnant. I knew exactly when I got pregnant. I knew the second I got pregnant. You bastard, what's wrong? She's ready to sue the doctor. My youngest brother has an IQ of 160. Holy shit. It's like 30 points higher than anybody else in the family, I know. So he's smart, you know, no damage was done to the kid. He's pretty, right, Mose? Tell him how pretty he is. He's a spoiled little runt as well. Well, he's taller than everybody, so that's not really quite fair. So who's the shortest one in the family? It should be him, right? Because he's the youngest, he should be the runt in the family. He was the tallest one, wasn't he? She's seen the picture of my brother, all my brothers, all of us together, and my dad. Most traits are determined by many different genes. This is known as polygenic. The genes that are expressed are a person's phenotype. Who's the shortest one in the family? You. And me, yeah. Who's the ugliest one in the family? Yeah, okay. Me and my other brother, my 2 middle brothers, we're the ugly kids in the family. The genes that aren't expressed are known as the individual's genotype. A person's genotype or unexpressed genes are only important when they are reproducing or when the individual needs to match their gene structure with someone else's tissue, as with a blood transfusion or transplant. So the phenotype is really all that we're looking at. You know, when you look at somebody, they've got brown eyes, they've got black hair, they've got a heavy beard. You know, all of these things have to do with your phenotype. Your genotype has to do with the ones that aren't expressed, the genes that aren't expressed. Now, normally this doesn't affect anything unless you're reproducing, because sometimes when you're reproducing, the recessive genes are the ones that are expressed. So my brother he impregnated his wife. The baby that came out had red hair. Well, mom has brown hair, my brother has brown hair. So how in the world did they ever have a red-headed baby?
Recessive generation.
Exactly. There's a recessive trait from somebody back in the bygone era. Exactly. So this is only important when you're reproducing or when you're trying your tissue typing or you're typing somebody's blood type. Your blood type, everybody tends to have a fairly common blood type, but sometimes we will have a reaction between one type of blood and another type of blood, and sometimes that has to do with the genotype. So we have to look at the genotype anytime we cross-match blood. So it's not like we go, oh, he's an A, so I'll just throw A in that kid's body. You can't do that. You have to match his blood with the donor's blood and make sure that there's no reaction. And it's called blood typing. So, despite the fact that you're, I don't know what you are, but if you were A, I would give you A, but I have to check it to make sure that there's no reaction. And sometimes that reaction will be 1-800 number. What do you think? It's my wife. So the blood transfusion or a transplant, if we're trying to transplant, you're trying to donate a kidney to your cousin, we need to make sure that you and your cousin have the same type of blood. Because potentially you're not that closely related, right, to your cousin. You have only 1/4 of the genes that they have. And so 3/4 of your genes are different from theirs. So if you were trying to donate a kidney to your cousin, we would have to type your kidney to make sure that there wasn't a problem, that they wouldn't reject your kidney. And probably, despite the fact that you have 1/4 of your genes are the same, it probably wouldn't be a match anyway. We would have to find somebody out there to match their. And this is one of the reasons why it's so difficult if you need a transplant, to get a transplant. Because we have to find a perfect match. Otherwise, you'll reject the organ. And we don't want that to happen. We don't want to waste anybody's kidney. I used to do this kind of stuff all the time. Cross-matching blood, checking for genotypes. Most genes are non-additive. One gene is dominant over the other, and that is the trait that is expressed. Black hair, for example, is a dominant trait. Good eyesight is not a dominant trait, as strange as that may seem. 6 fingers is a recessive trait. I don't know if you know anybody with 6 fingers. It's really kind of weird. I had a friend who all of his babies had 6 fingers. He had 6 fingers when he was born, and of course they cut that 6th finger off. How are you going to find the loss, right? and he had this 6th finger grown out of the right here in the palm of his hand.
He would have been a good guitar player.
Really? 6 fingers. Okay. It looked like a little finger, but it was growing out of here, and they really didn't have any muscles connected to it, so they just chopped it off. Well, chopped. That sounds like they hit it with an axe. They took a scalpel and very carefully cut it off. So they all have these scars in the palms of their hand. It's really kind of weird. However, there are some genes that are additive. In other words, the expressed traits are a combination of the genes, so that one is not dominant over the other. Height tends to be that way. My mother's only 4'8", my dad's 5'7", and all of us are somewhere in between, except I have 2 brothers that are like 5'10". Don't I know those bastards? It's my oldest brother and my youngest brother are both that tall, and I'm like 5'6", 5'7". Damn it. Why couldn't I be the tall one? You know how fast I would have been if I were 3 inches taller? I don't know either, but I probably would have been a lot faster than I was. Height is that way. Skin tone tends to be that way. So if we have 2 individuals with very different skin tone, somebody that is of African descent potentially, and somebody that's a very pale Caucasian, a lot of times we get, the kids are somewhere in between because it's an additive, it's additive. I had a friend when I was in the service, he was black and his wife had the reddest hair you ever saw. She was the bluest person I've ever seen. She had no skin tone whatsoever. What he saw in her, I have no idea. She was so pale, you could see her heart beating. I never saw her chest, but I mean, it was that bad. Anyway, their kids were right in between, except she had one kid that was really, really dark like he was. It was really kind of weird. So when they walked around, people didn't think that they were related at all, because they've got this black kid and then everybody else was somewhere, they were relatively light complexion. And that's what we're seeing in this picture as well. We've got one kid that looks almost white. We have one kid that looks almost as dark as her dad, and then we have one kid that's somewhere in between. Skin tone is additive. While most genes are either expressed or unexpressed and are tied to dominance and recessiveness, some genetic structures are adaptive and can be expressed by conditions in the environment. The study of genes is referred to, of these genes, the ones that are expressed in this way, this is known as epigenetics. So your epigenetics are different than mine, potentially. I was born in Indiana where it's colder than it is here. You guys are born in Arizona where it's hotter. However, if you're one of the individuals from Saley and you were born in the wintertime, potentially your epigenetics are different from the Navajo that live closer to Holbrook, because that's more deserty area. They don't have as much cold weather. We are at 7,500 feet right now. Holbrook is like 4,000 feet. That's a lot. That's a lot of difference between the two places. So potentially the epigenetics of somebody living down in the desert and somebody living up here in the mountains is completely different. Not only that, but you're going to grow up in an environment that is not as oxygen rich up here as it is down there. So your lungs are going to be bigger than theirs is. Theirs will be, potentially. And a lot of this has to do with epigenetics. In order for you to survive in this environment, you need to be able to handle the oxygen level of 7,500 feet. There's only 2 cities in the United States that are as high as we are right now. And it's not Denver. Denver's only at 5,200 feet. So even though people complain about Denver, it's still 2,000 feet lower than we are right now. The 2 cities are Flagstaff and Santa Fe. If you drive from Albuquerque to Santa Fe, you're going uphill almost the whole time, as weird as that is. So living here, when I went home to Iowa, which is 400 feet, from 7,500 feet, I felt like I could have run around the whole state, because, you know, I've been exercising at 7,500 feet. So I felt like I could conquer the world. Had all this energy down there that I don't have up here. Well, anyway. I know, I was so excited. So epigenetics, it all depends on where you are and how much humidity there is in the air. The Japanese discovered this during World War II. They tried to take the soldiers from Hokkaido, the ones up north, where it's cold. Southern Japan is relatively warm almost all the time. They have very rarely get snow. They tried to take those soldiers and put them in the tropics. It didn't work. Those soldiers died. Very frequently they died because they sweat too much. When you're in this kind of a cold environment, you sweat. You get used to that. Your body develops more sweat glands. So in a colder environment, you develop more sweat glands. If you live in the desert, if you're from Phoenix, you don't sweat hardly at all. Because if you did, you would dehydrate and you would die. So people that live in that type of environment, their epigenetics are totally different than yours are. As strange as that may seem, it's so that we can adapt and we can survive. I like surviving. It's a lot of fun. The study of these genes is referred to as epigenetics. These genes can be influenced by such factors as nutrition. What if you don't get the right food? The climate, and I just talked about the climate, medical care, the lack of medicine that you get, economic situation, culture, historical context, all of these things affect your epigenetics and how your epigenetics are expressed. As weird as that may seem, let me give you an example. Let me give you an example. We had a problem when I was young in that the only antibiotic they had was penicillin. They had 2 drugs. They had sulfa drugs, which a lot of people had a reaction to, and then they had penicillin. And you could give penicillin to just about anybody. penicillin won the World War II, in essence, because they would give a shot of penicillin or sulfa. They put sulfa powder on a wound, and the people wouldn't bleed. They wouldn't die of an infection. All of this stuff was going on. So when I was a kid, if I got tonsillitis, they gave me a shot of penicillin. If I had a cold and I couldn't get over it, they gave me a shot of penicillin. So because they gave us so much penicillin, we developed the bacteria, and the viruses developed a resistance to penicillin. Now you guys have all, anytime you get sick, they give you something else. They don't give you penicillin. No, they never give you penicillin. And the reason they don't give you penicillin is because my generation took so much of that stuff that we made all these bacteria resistant to it. And it's very rare to give anybody a penicillin shot. And of course, one of the examples of a bacteria that we treat with penicillin is gonorrhea. Yeah, it's Gonorrhea Syphilis, actually. And those have not developed a resistance against penicillin, except the stuff in the Philippines. We came across a penicillin-resistant strain of gonorrhea in the Philippines, and then it was spread to Vietnam. So what do you do with that? At the time, we didn't have an antibiotic to treat it with. So what do you do with those guys who were infected with gonorrhea? I don't know where they got it. Off of the toilet seat, I think. I'm pretty sure they got it off the toilet seat. Toilet seats are dangerous. You gotta be really careful. So what do you do with somebody it has penicillin-resistant gonorrhea, and you don't have any other antibiotic to give them? Yeah, we quarantined them. I like that word, quarantine, instead of locked them up. Yeah, well, we had to do something with them. We couldn't send them back into the culture. Anyway, so that's a good example of medicine that used to work, but it doesn't work nearly as well anymore. Each DNA structure has extra genetic material that was previously thought to be excess and unnecessary material. They refer to that as junk. We had all this junk DNA in there. But geneticists have discovered that when methyl groups are added to this extra material, it changes the gene to either express or to turn off the gene. And this is known as methylation. Now the problem with marijuana is that it creates methylation in 600 different sites on your DNA. Now there are billions and billions of sites, and we've only found 600. But we've only found 600. That may mean that there are more. So the methylation process that is taking place, that is caused by the marijuana, may potentially cause a mutation that we haven't seen yet. It is thought that this is how humans have been able to adapt to different environmental stressors with all this junk. As exciting as all that is. Epigenetics appears to come into play the strongest during the prenatal period, just before and just after birth. Thus, when infants are exposed to environmental stressors early in life, such as pollution or family conflicts, it may affect their reactions throughout their lives. Asthma is a good example of living in a polluted environment as an infant. About 40% of the cases of asthma, if we take the individual out of the family, the conflictual family environment, their asthma goes away. About 40% of the cases. As weird as that sounds. So if you have asthma, if you are allergic to anything, potentially we can take you out of this environment and put you in another environment and you won't be sick. Or if you don't have any hay fever or any asthma, and we move you to Iowa, where there's a lot of maple trees and oak trees and totally different environment, potentially you'll develop an allergy to that substance. I had a friend that lived in, where were we? Nebraska. Lived in Nebraska almost all of his life, had no problems with hay fever, moved down to Phoenix, and he developed and then he went back to Nebraska. an allergy to hay. To hay, they make a lot of hay up there, so you develop that strange allergy. As weird as all this stuff sounds. So the reality is that we are products of our environment, no matter where it is. So when I tell you that I'm from Indiana, Indiana is very humid. It's very much different from your environment, which is relatively dry. We don't have any pinyon trees in Indiana, none. We have hardly any evergreens in Indiana. So potentially I could develop an allergy. I live in a pinyon forest. Well, we all do if we live here. So potentially I could get sick from this stuff. Or because I've never been around it, I've never developed an allergy. You may be allergic to pinyon. And when it starts snowing, all that yellow stuff in the spring, doesn't it? It's all the, I don't know, it's trying to reproduce. So. Has something to do with testes, okay? So be careful. Anyway, so we are products of our environment. And that's a reality. So if you were born in the valley down around Phoenix, the environment that you lived in and have been around, if you've been around all of the exhaust of God, the exhaust will not leave that valley. It just never blows out, does it? It always smells like exhaust now. Everything smells like diesel. As much fun as all this is. And that is the end of the chapter. I know I'm 2 chapters behind. I'm trying to blame somebody. I'm thinking maybe Travis. No, how about Chris this time? It's Chris's fault. He just won't shut up in class, so I think it up. Sharon's back there just gabbing away. Wow. Is she trouble, Travis? No? I'll see you guys next week. I know I'm behind. I'll catch up. I'll start going faster. We're going to talk about stress next. I have a quick question, Travis. Yeah, if I could. I'll come back here. Okay. I'm on my way. This is this has to do with I bought this for you. That's not the deal is, theoretically it comes from that mountain over there. The squirtle?
Yeah.
So he said that he was a teenager, climbed up there, and he's not supposed to go up there. Nobody's supposed to go up there. But he went up there. And the spear point, he found it up there. And he brought it back. And he made it into a spear. So my question is, supposed to do this? I know it's not. Get up. I just want to make sure I'm not.
Yeah.
I'm not stealing your character.
No.
I don't think so. I'm good.
Yeah.
Okay.
Yep.
Okay. And if anybody asks me, I'm going to
Yes,
tell them
tell us
it's your fault. Thank you, Travis. You make me feel much, much better. Excuse me.
If you could explain this a little bit better. Okay, so what exactly, the female part that you talked about?
Yeah, we'll see in those.
What am I seeing right here?
You're seeing everything on the left is probably the female. Well, it is the female because this is on the left. So everything on the left is the female.
Okay.
And everything on the right is the male. And as you can see, they're not the same.
Okay. So this is the makeup of a person.
Right, yeah, this is a genetic fingerprint. And very rarely do we see, well, no, we don't. Well, maybe that one. And maybe that one. They look alike.
Okay.
That one maybe. But as you can see, these two are pointing in different directions.
So the left side is all female and the right side are all male?
Right, yeah.
Okay, and with there's 23 chromosomes within a person, and then together they're supposed to make up that 46?
Exactly, exactly.
Okay.
So now they've got blue eyes because of whatever's there. You know, they're 6'8" or whatever because of the genetic structure. And potentially, it depends on what is dominant, what is recessive.
Okay.
For the longest time, they said that anything dark was dominant. So if a African American made a baby with a Caucasian, and in this case, we're actually just talking about skin tone. If they're talking, they thought they were talking about everything. The baby would turn out black. The baby would be black, no matter how white she was. But now we know that's not true.
Okay, so every time I see this left side is female, right side is male.
In this case, we know that that's, yeah, and usually that's the way we do it.
Okay.
Female will be on the left, male on the right.
Okay.
So when you have children, depending on what your wife is, you're married, aren't you? You're not married. Oh my God, no. Sorry.
That was funny.
Depending on
That
what
was a
she
good
looks
one.
like, she may look like you, or they may look like your wife.
Yeah.
The different aspects. She'll have your nose. The baby will have your nose. He'll have your wife's eyes.
Okay. Okay. Now I'm just trying to figure it out with
Hopefully you'll have your wife's personality.
with nephews and nieces how they look like.
Right. I was trying to tease you, Chris. Did it work? Okay, good.
Oh,
He's from one of those.
yeah, all the top three.
The top three. So you guys are going someplace else?
No, it's just every 2 weeks it's new. Yeah. If we're not doing so well, then we don't get to shoot.
Oh, shoot, that would be a tragedy.
So the whole program's based on like academics.
Of course.
Make sure like before we're failing, they want to make sure like you get resources like tutoring or like we won't go to practice. We'll have study time, mandatory study time, library time.
I'm really sorry that you ran into those racist pricks at Las
It's
Vegas.
fine. But I just like left it. I just kind of like blocked them out. I didn't really care like to a certain point. Like why should I have feelings? Like kind of like
Why should you allow them?
allow those feelings.